Hello again, folks, and welcome to the fourth video in the series here, where we're working on making a buck voltage regulator for a Raspberry Pi. In previous videos, we've covered selecting our parts, creating footprints in Eagle, setting up the schematic, and in this video, we're going to cover at least starting on working on the board layout. Usually, the board layout is kind of the longest piece of the puzzle, takes the longest period of time, so I'm not sure if it's going to make sense to fit it all into one video, but we'll see where we get. With that in mind, I did come back to the schematic we had and make some slight adjustments. I realized that I forgot to actually put output connectors on. You know, we in the last video had labeled our outputs and our inputs, but didn't actually provide any pads on the board for connectors. So I added some devices here, and you can see them. They're real quick additions. And then, you know, we discussed also kind of in passing, they have an optional component in the reference schematic, this Zener diode here, to prevent overvoltage when we shut off current. The coil here is going to is often going to generate a significant voltage spike, and so what the Zener diode here will do is it will clamp that voltage down, prevent it from going too high. So I threw that in there as well. You'll note that we did a 6.2 volt Zener here. We may be able to cut that a little closer to our 5 volt regulation voltage, but Zener diodes aren't as strict, you know, hard cut on sort of thing. They have a knee to them, and through part of that curve, they'll start conducting even if they're not conducting all the way at a lower voltage. So we want to avoid the losses that will entail, so we have to put our you know, selection voltage higher so that we avoid getting into that knee during normal regulation. So that's why we chose a 6.2 rather than, you know, just above 5. So we'll get into working on the schematic here. Not the schematic, the board layout. And like I said, you know, this can often be the longest portion of this, but that's the way it is. So Eagle starts us out with all the parts that we created in the schematic off here to the side, and then a big old square to put all of our parts in. And then usually I kind of like to set some general boundaries early on to make it a little easier for myself when I'm placing parts. And so I'm going to make the board width the width of the connectors. Make it fit well. And so what I'll do is I'll place that there. And then I'll do the same kind of with the output. And what I'm going to do is also, for some reason, it puts it at odd values like 6.299, etc. So I'm going to put this at, you know, at some even values, make those a little bit more square, and there we go. And so now when I drag these in, they'll be a little bit nicer to work with. So I don't actually expect the board to be this long. I'm just giving myself plenty of extra room. And so what I'll do is I'll make the input here, and as we build these parts in, then when we figure out what the length I need is I'll just pull the output port in. So we just won't actually get to connecting this until the end. So I'm going to start going and grabbing components here, and often here we're going to want to reference our schematic here. And so when we see we have parts like C4 and C5, these input capacitors right off the input, I'm going to go look for those right off the bat here. So I see C4 and C5 right off the bat. I'm going to just kind of loosely place them near the input. We have our R3 100K. It's also going to feed straight in. So go find our R3 100K there and put that there as well. And I think that's a good start. We've got our direct input pins, and then we'll have the regulator chip itself. So I'm going to grab it and kind of plunk it there, and then I'll do they call it a rat's nest. You hear at the bottom when I hover over it is going to also say calculate shortest air wires. All these little yellow lines are what they call air wires. Is they're saying there's supposed to be an electrical connection here, but you actually haven't drawn the routes for them yet. And so we're just giving you an indication that these exist. But when you move these around, you know, the air wires stay where they are. So even if it's not the shortest route, this is especially true in like grounding scenarios, even if things aren't the shortest route, when you move them around, they'll keep their existing routes. So you calculate your air wires and it cleans things up and makes it easier to see. So I'm going to come in here and do that, and then the other thing I'm going to do here is that I'm going to create some ground planes and make these easier to work with too, because what will happen is that when I create the ground planes, I'll label them as ground, and then Eagle will know to treat them as a ground electrically connected, you know, connection, and so it will use that and calculate the air wires based on using the ground plane rather than actually having to connect each ground pin together individually. And so with that, if I give this a name and call it ground, then I should be able to calculate the air wires and see that this ground pin here, Eagle is automatically connected to the ground plane. So you know, at the same time, I'm going to use this tool. This is the rip up tool. So this is, you know, when you place a trace, you route a trace, you know, you can also rip that trace up here. So I'm going to rip up this ground plane we just did. So the plane still exists. We've still got our polygon shown here. I just pulled it out from being calculated. And so this way, Eagle says, oh, I've already calculated the rat's nest wire here. You know, I calculated it based on this ground plane, so I'm not going to show it to you. I'm going to clear this off. But you also don't have your planes, you know, kind of get in the way of easy visibility. So, that said, we've got, looks like this will be our ground pin, and this will be our positive pin. I don't think that's actually what I want. My connectors, the way they work is they will have the, you know, if the connector faces off the end this direction, you know, the right side here will be the red side. And so I want to actually flip my connector there around and make that a little bit nicer for when I actually go and put this thing together. And then with that, I have these capacitors. And so we have the left side here, you know, it automatically connected this side as the ground. So this side will be our input voltage, and so we want to make sure that we get those aligned properly. And probably what I'm going to do here to save some space is I will do something like this. Yeah, I'll do something like that. So it keeps a little bit of space, but it saves the horizontal space here. Again, we've got this this little resistor here, and it needs to connect to this pin over here. And I'm gonna, you know, because when you select it, you can see what air wires are moving with it. So we have this pin over here that it's going to be connected to, which is our voltage input pin. And then we have our pin over here, which is the direct pin it's connecting to, which is going to be our enable pin. So I might actually place this one over here, kind of like this. Well, actually, I'll probably, let me make my grid a little smaller here. There we go. So I'll place it here in line with the enable pin, and then I'll worry about actually running the voltage input around to that. So then we're going to come down to things we start attaching to the chip itself. Now it's kind of every part, every device, every project is going to be different in this regard based on how you want to orient parts and how you want to route traces to and from things. In the case of something like a switching regulator like this, the connection between the switching output here, ground, and your inductor, your main inductor, is going to be critical. You need these to be as short as possible, as high of current as possible, and then everything else is somewhat less important. So I'm going to take our switching regulator here, and the next part I'm going to choose here is the inductor, and see if I can fit these on in a way that I'm happy with. Now, part of this is that this inductor is very big, so we're going to want to, it's going to make placement of other parts more difficult. But with that said, the other side of our inductor faces directly to our output, so it makes it relatively easy to say, okay, one pad on this inductor is just going to go straight out, and then the other pad comes into our switching pin here. So that makes it a little bit easier. So switch that around, because we know that this side here is connected to the switching regulator, and then this side here connects to the output. So, and you'll actually see, because these are opposite end launches on this board. So the right hand side off the end will be this side. So our voltage output is on the right, and as I said, the right side of my connectors are the red side. So this connector is already proper. So it's just this one that I had to flip around to get the right on the red on the right hand side. So that's that. So that's taken care of. And then actually what I might do here is that, because this is kind of a long distance between the pins, is I'm probably going to grab my regulator here and flip it on its side. Grab that up there, and then what I'll do is I'll move this pretty close. Yeah, I think I'm happy with that. And so then it comes down to is laying out the rest of it in terms of getting your high current traces through. So, and this is our Zener diode here. That's also referenced here on the schematic for our protection. So the other thing we want to throw in here, because this is also tightly coupled here with our inductor, is this C7 capacitor that goes back to this bootstrap. So we want to go find C7 and make sure that when we're laying all this out, we're including it in our thought process here. So placing it, if I place it something like this, that could work okay. I'm not sure I'm happy with that, but what I can do is I think maybe if I do something more like this, where I move the diode down a little bit, then we can get these closely coupled. This guy comes in more easily here, and then all we have to worry about is this one connection out to our, in this case it's our voltage input. And so that question, I'll probably solve that with a via, is I'll put the voltage input coming in on the bottom. So that'll make things a little simpler for me. So, I might as well, plunk that down there. That seems about reasonable. So, with that said, I think that that leaves me some decent space. Let's see how wide this board is. 0.7 inches. That's okay. So 0.7 of 0.325. I'm going to move this inductor up just one, put it right in the center of the board, and that's just me being, pedantic and wanting things to be centered and nice. So let me see about putting some traces on. So now we've got, a little bit of basic structure here. So I'm going to see about connecting, in particular this most important trace here, referenced by this yellow line, between the switching output of our regulator and our inductor. So we want this to be as big and thick and fat as possible. So, maybe I'll start with a 0.86. You can see that's a big fat line. That can work, and then you have to narrow it down to actually fit onto the pad here. So now when we do a rat's nest, it now separates this. And this is what I was talking about when you rip up the ground plane. It can help with visibility, just because when you're laying traces on the top, they don't show up against the ground plane. But if I do a rip up here, now all of a sudden when I'm routing a new trace, all of a sudden it's much easier to see. So I don't have to redo the air wires in the rat's nest to actually see what's going on. So we will do, and I'm right clicking here. You can see along the top up here, that it's switching between different modes on how it will orient traces. And that's just, I'm trying to select something I like for getting the trace set up nicely. So that would be that. And actually I'm going to say our input trace needs to be relatively high current. So I may not actually put that through a via. What I'll do is I'll put our bootstrap connection here through a via. And so I'm going to move this up a little bit, and I'm going to take this and do another like that, and then I'm going to make this wider. I don't think I can go quite as wide and still fit between all the parts I have here. And I'll do like this, and now I can get a little bit wider and start coming out. And for right now, this is just going to be junk. It's not actually connected to anything, but it kind of gives me the idea of where I'm going with this. So then I'm going to adjust positioning of this little guy. I'm going to redo my air wires, and so now you see things start recalculating again. So now I'm going to do this guy. My bootstrap needs to connect to this pin, so I'm going to do a new trace. And so in this case, I'm going to start on the top. We'll go back to a relatively thin trace because we don't need to carry a lot of current there. And I'm also going to move this capacitor in, so I'm wasting less board space on it. So we'll go to routing. I'm using a relatively thin trace. I'm going to tell it to use a round via, and I'll expand this. And my board house, the place I use, will support 13 mil vias. So I will stick out a little trace there, and I'm going to, so I'm in the middle of still routing, but I'm going to switch my layer now. I'm going to switch to bottom. So I'm just going to jump up here, and that looks pretty good. And then switch back to top. And so now I've got starts on the top, jumps through this via to the bottom layer trace, jumps back to the top, and then comes back. And then I'll see if I can adjust my positioning here, make that a little nicer. That might be a little close for the design rules, and so I can actually check that. There's this design rule check tool. And so I'm going to load some design rules. By default, it has some random default ones that don't actually have anything to do with your where's my with your board house's actual capabilities. And so I'm going to load the design rules that are provided by the fab house that actually tell me what they can and can't do. So in this case, they're saying no errors. It went through the check. So this spacing is good enough. So I'm going to leave that as is and not worry about it. So as we go through and place things, we're just going to want to make sure that we check in every so often and make sure that our design rules aren't where we're placing things aren't compromising what our manufacturer can actually put together. So that's kind of our high current side of this. So then we can start narrowing the field down even more. So we have C1, 3, 6, and 8 are all of our output capacitors here on the inductor. So those are easily placed. We just dump them over here and can get back to them later. So we have 8 and 3 and 1 and 6. So we'll stick these guys over here and we'll rat's nest to make that a little easier. And so then what I'm kind of going to do is I'm going to place them, somewhat opposite, making sure to place the grounds, away from the center. Except for that guy, I can fix that. And then what I'll do is I can run a high current trace right out the middle and connect all of them. That'll make it a little easier. So those are out of the way. And so as you see here, we're narrowing our field of components that we still have yet to place. And so as we continue to do that, we will eventually run out. And as we place things tightly, then we can move whole groups of components in, and then continually iterate on making things tighter and smoother in terms of placement. We'll just do an iterative save here. And so let's see what components we have left. We have R1 and R2. If I recall, those are our voltage set ones. So those go into our feedback pin, but importantly, they go together. They're a pair. So instead of placing them at two different random locations, we keep them together just like this. So in this case, we have one of these is going to connect into the ground plane, and the other one here connects to our voltage output and then our feedback pin. So I'm actually going to see about placing these so that they kind of go side by side here. Take up as little space as possible. So these two here will be connected here via this little air wire. They'll be connected to the feedback pin, and then we'll also connect over to our voltage input. Our voltage output, apologies. Again, these aren't terribly high current devices. These are just kind of getting a little sample of the voltage and telling us where we're at, so we don't need a big high current trace for these. And then we'll go over and sample that voltage. Alright, so those are placed. So next we have R4 and a couple of capacitors. So let's look at what R4 does. So R4 is actually linked with C2, so those are going to be a pair that we're going to want to work with. So C2 here. Oh, I guess I'm still in routing mode. Go to move mode. So C2 here. And R4 here. And so if I do another air wires here, so yeah, one of these connections on R4 is a ground. The other connects to this capacitor, which just connects to this pin here. So that makes that relatively easy. So I'm actually probably just going to move this up just a little bit and move that up to match. And then put in a route. And route that one. New air wires, and all of a sudden those are connected and done. So we don't have to worry about those anymore either. So all that's left now is the C9. Let's see what C9 is. So C9 is our soft start, and it just goes to ground. It should be another easy one to route. So all we're going to do here is grab this guy, and I'm actually probably going to swap its location with this 100K. So I'll do something like this. So now we have the C9, and we can route that in. That's taken care of. So now we have this 100K capacitor that's, not capacitor, resistor that's left, and it can actually kind of just slot here in the middle. Makes that easy. I'm going to route this over to the enable pin there. And so then what we'll do is that as I pull this whole group over this direction to meet up with our input connector here, is it'll mean that since our input's up here anyway, it's going to be close to where this input is. And so as I'm rerouting this big fat high current trace, is I'll also just connect this one in. And that should take care of pretty much all of that. So let me see about doing so. I'm going to shorten this up and make it not stick out, in the way. And then I'm going to kind of tighten everything up a little bit, and then I'm going to select the whole group here. And like I said in the last one, it's going to be select the group, and then for Windows I think it's Control, on Mac it's Command, and then you right click and you can move the whole group. So I'm just going to take the whole thing and slide it in. And so you can see here where we have this kind of opening here. So what I'm actually going to do is, I had placed these up here a little bit. I'm just going to slide these down. They can fit in that opening, and it means the whole thing can slide in a little bit more. Everything a little bit more compact, and the more compact we can make it, the less we'll spend on the actual board itself, because the board manufacturers charge us by the size. So make it easy. And I'll probably separate these so that I can run that high current trace right through the middle. Because if this guy is up here like this, I have to have room to put this high current trace up and then over. So if I move this down, I avoid the ground side of this, and I can go kind of straight over and then diagonal up to the input. So that's what I will do. And so now again I'm going to grab my group and move the whole thing. And I think that looks pretty good. And I'll plunk it in there like that. Redo our rat's nest. So then I'm going to go back to routing. I want to remember how fat this trace is. That's a 0.07 trace. Okay. So I'll go back to routing. Go back and select my 0.07 just so that I'm keeping the same width. And finish routing that out. I'll finish routing to there, and I'll finish routing to our input. And so that big trace is taken care of. And so now you see that we've just got this one little guy left, and that should be an easy one to take care of. That can be done with a little small trace. And I'll just go like this. Alright, so now you see where we run into a little bit of an issue. So as soon as I added that, you see that now there's a new air wire between these two. And that's because I separated these grounds, is that you can see here that this portion of the ground connects out this direction, but it's not actually connected to our input ground anymore. And so what I'll do to solve that is, like I added a top layer polygon for a ground plane, is I'll do the same on the bottom. And so we'll have a dual ground plane, one on the top and the bottom. And then we'll tie them together with vias. That way we make sure that they're well connected, we can handle a high current through them, and that it allows us to pull up ground from underneath and make sure that we don't have any islands there in the middle that don't get connected properly. So you see we've poured a new blue ground plane underneath. That blue represents our bottom layer. And so all of a sudden our rat's nest wire went away, and it went away through a very circuitous reason. But what happened was we added a blue ground plane underneath, which connected to our ground pin here, and then way over here, it also connected to our ground pin over here. And so it came up through this side, back onto the top layer here, all the way back over, through under this part, and then back to here. So it's a very circuitous ground, but that's what it did, is it fixed that. But what I'm actually going to do to make that a little nicer is I'm going to directly add a via, and I'm going to stick it there, and I'll just do this one, and then I'm going to do a name. So I'm going to electrically force this one into the ground layer as well. And so now we're directly connecting the top and bottom ground layers right here. And so we can use this to help with grounding in certain locations, as well as we'll add a bunch at the end just to ensure that grounding is uniform and solid all the way through. So now all that's left is that we pull these things in, pull our output connector in, and then we'll work on cleaning up our labeling. So let's go and start grabbing these guys. Now, one thing to note, as I said, we're going to work on cleaning up our labeling. It doesn't really matter right now if some of our labeling is overlapping with other things. We can worry about cleaning that up in a minute. What we'll do is when we defined, as we went through in the second video, when we defined our parts, our footprints, we also put in some text labeling. And we have an opportunity now, now that we're actually placing these parts, is to move the labeling independent of the parts. And so we'll get to that here in a minute. We can make those easier to see. So then we'll grab our output connector here and pull this in. And I think that looks pretty good. I usually don't like to leave this much blank space, and it also gets kind of odd with the route, but I think I'm okay with that. So I'm going to go again, grab a nice fat trace here, connect these two, connect it into this guy, and again, all right. Now the other thing I'll note is that I don't think our connectors are terribly well centered, but I don't think I'm going to make too big of a fuss out of it. They're relatively close to center, and I'll probably call that good. They're slightly off. I might take you got our X and our Y positions. I might drop this down, I don't know, 0.195, drop it down, and that looks a little bit more centered, so I'll call that I'm happy with that. And this guy might need to go up a little bit. You see it's a little closer on this end than this end, so again, our Y position up just a little bit. I think that's pretty good. So, and again, that's doesn't change anything electrically. It's just me liking things to be centered. Keeps things nice. So that's pretty much that. So now the last part of this is that we will pull in the ends of our board and the ends of our ground planes here. So now our board is much smaller because we don't need it to be huge. And so we see here at the top, I've actually rather conveniently, I made this, as here we've got our indicator of where we are on the map in position. So we've rather conveniently made it exactly 2 inches long. So that makes it pretty nice. And then it's 0.7 inches wide. So 2 inches by 0.7 inches. Should be a relatively small board, should be relatively cheap to have made, and should be exactly what we need to get this job done. So, one thing I might actually do, though, is that I'm seeing that we're a little close on this side than this side, and I don't think I need to make the board any smaller. I will just move the inductor over just a tiny little bit and give a little bit more room on either side, just in case there's tolerance or giving me a little bit more room to solder components on either side. It'll go a little easier. So we'll do another little incremental save there, because you hate to lose it. And again, run our rat's nest, easy peasy. And so now we're pretty well close to done, electrically. So let's do an electrical roll check, and this check is really going to make sure that we haven't, crossed any wires or made anything that's inconsistent with the schematic. And so we see here, there's no errors, no warnings, board and schematic are consistent. So electrically, we're all good. Assuming our schematic is good, of course. Eagle can only go based on what we tell it. Then we're going to do another design rule check. We'll check this again, check for issues. And so here we're seeing we can find out what our issues are. So what it's telling us here is that this pad here for the inductor is overlapping with our keep out area here on this capacitor, the clearance. I'm okay with that. I don't think that's going to be an issue. So we go and start checking things. Our dimension here looks like we're a little close to our edge of the board here, is what it's complaining about. And let me see. So when we look at the properties here of the polygon, we can adjust like what spacing we keep on the polygons away from things. In this case, we're looking at our dimension layer. This is that white line, which represents the size of the board. So what I'm actually going to do is I think that's probably okay. I don't think that's going to be an issue for us. So I'm going to go look at our issues here, our copper to dimension layer, copper to dimension distance that we require. Right now we're setting that as 15 mil. I think we can drop that to 13 without an issue. And we'll recheck that. And so see, we took those errors disappeared. So we don't have to worry about that. I think that this board will print up fine. But the other option you have is to just pull this capacitor in. That's a big jump. So I'll probably just manually adjust this. So 0.65 to 0.645. Pull it in just a little bit. It's going to get it away from that edge, and it's going to fix up any errors you see. So again, we can rerun our design rule check that. So Now what's our remaining errors here? So we have our keepouts. Yeah, okay. So what really this is complaining about is that it thinks that these resistors are placed too closely. These red lines you see around these resistors are what they call keepouts. Is basically saying I need this much space around this resistor to for whatever to be placed effectively. Often this will be caused by you know, any machining you're trying to do, any pick and places or whatnot that may have issues with placing parts really close together. In this case, you know, I've already done parts this close together. I know it's not a big deal, and I'm assembling it by hand anyway, so I don't think that this is going to be a problem. So I'm going to ignore those. And so I think all of these design rule errors are things that we can live with, or things I'm happy with that I'm not concerned about. So I think now we're happy with our layout. I think we're happy electrically and based on what we can actually manufacture. And so now the last bit is our polish. So polishing, we're going to, you know, really connect our ground planes really nicely. We're going to stitch those things together with these ground vias, and then we're going to work on our labeling. In this case, I think I'll probably work on the labeling real quick first, and then work on the ground stitching afterward. That way we can place our labels someplace nice, and then stitch around them, because, you know, depending on how you have the board manufactured, you can't place labels over vias. So that's okay. So what I'm going to do is, there's a tool here called Squash. So if I right click here, or sorry, Smash. It's going to smash this input connector here, and it's going to separate the connector itself from the text layer. So now I can move this text layer independently. And so what I'm going to do is I'm going to put it up here, but I'm actually going to, they have this option called mirror. I'm going to mirror it and put it on the bottom. And go back and move this. So now, if I look at properties, it was T-place, and now it's B-place. This is the bottom placement layer. This is the silkscreen layer. And so now it's going to be printed on the bottom of the board as the input here. So that's going to make that pretty easy. I'll actually add a text layer, as I'll do a plus here. And again, we're going to do a vector. I'll probably actually make this bigger, because we got room. And I'll put this on the B-place layer. And stick it there, so you can see it there kind of underneath. And then I'm going to do the same over here, because having indicators of our voltage points is always good. So I'm going to put that there, and then I'm going to do a new text layer, and instead of a plus, I'll do a minus. And so, again, place that there, so B place, so that's fine. Place a new one over here, B place. Perfect. So now we have indicators on the bottom of the board of input, plus and minus, and then I'll come over here and move the output one as well. Move that just a little bit like that. And then, again, we're going to smash this package and move this output label. I'm going to mirror the output label, and then move it into place where I want it. I think that should be okay. And so we'll continue doing that on these various parts as needed. So in this case, I think we have plenty of room, so we can fit both of the part number. And again, I'm probably going to drop my grid value here down. Give us a little bit more precision when we're placing labels. And so I think we can fit both the part number and the value next to these parts. So I think this one's probably going to be okay to start with. This one, this would be printed off the edge, so we'll smash this, and then move this up here, just like that. So that's printed alongside of it. There we go. I think that's better. Okay, so this one, this 10UF value here might get a little kind of mixed here with the line, so I'll move this. Move that like that. Again, move that there. That should be okay. And then that should be okay. Yeah, so now we've got these couple guys up here. Smash, 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 smash. And we're going to start moving these. 13K right there. And this is kind of a matter of preference. Do R1 there, and conveniently it shows us a line for which part it's associated with, and so we can keep these things relatively easily together without worrying too much. So that's there done. So now here, which one is C1, which one is C8. So again, we don't want to mirror, we want to smash them. Smash, and then move. So C1 is actually this one over here. And grab this value. C8 is this one here. Grab this value. Makes that a little easier. And then we'll do the same here. So we'll do C3 over there, C22. I think that should be pretty easy. And then we'll do C6 and 1UF. Just like that. And then, I don't know. We can smash this one too and move our L1 value over a little bit. Like that. So that, is pretty much that. So, like we did, we added some extra markers here. I usually like to add some additional markers. So I'll do, Nigel VH 2015. And so that's going to show up fairly large. We don't necessarily need it that large, but what I can do is if I do Nigel VH on one line, and again I'm placing this on the bottom, so that looks about right. Sure. And then I'll do a May 2015. May makes it a little wide, so I'll just do 2015. Alright, so that looks about centered. Perfect. That looks pretty good to me. So I think we should be pretty good. I'll add a little bit of text here. Buck Regulator. Just kind of give a general idea of what it is. I'm going to place this on the top because I can. We'll make this a little smaller so it actually fits somewhere. Just a little smaller than that. There we go. So that'll fit right there. And then I usually also like to put my call sign on there somewhere because I'm a ham radio operator, so I'll put that there as well. So that's pretty much that. So the last step here, like we talked about, is I'm going to just copy this ground via and start stitching it places. So in particular, I'm going to stitch it places that I want to make sure that grounding is extra good. You know, like this ground for the device here. You know, I'm going to put a few here. And I'm going to put, I think, 4 directly under the device. And this will cause DRC errors because it's gonna say the vias are interfering with the device. I'm pretty okay with that. And in particular, what I'm doing here is I'm connecting the 2 layers underneath it to help it spread heat through the 2 layers better. But I'm also going to make these vias bigger. I'm going to make these, I think that should be okay. I'm going to make these bigger, and so what I can do is it will help me solder the bottom pad of this device, is I can actually heat this up from the bottom and insert a little bit of solder, and it'll wick through the via and help to make sure that I've got the bottom of the device soldered well. So, and then that extra solder that's in the vias will also help with heat dissipation. So, again, we're just going to keep going through and copying vias around, make sure we've got good ground planes everywhere. In particular, I'm looking for places where like ground planes kind of come to an end, or where parts connect to a ground. You know, places where grounds are intersected by traces. Alright, I think I'll put one more just over here. And I may actually, as I'll move this L1 marker here, and then move this via here. Alright, I think that that I'm pretty happy with that. So we'll save that. And so the next episode, I suppose we'll make this, I suppose it'll end up being 6. So we'll do the next episode will be exporting the gerbers and sending this off to manufacture. And then the 6th episode will be on actually assembling the board once I get the boards and the parts all done. So thanks for watching, and I'll see you all soon.